So when we see these sort of problems, what we have to do is basically take the context of the problem and see if we can convert that over into an appropriate right triangle, and then determine what they're asking for in that right triangle. So first one I want to do here is 19. It says the grade of a road is 7%. So what angle does the road make with the horizontal? Okay. Does anybody know what we mean by grade of road? No? Okay. All right, so our roads, okay, I think the best thing to think about is when you guys are, and we could talk, grade of road, I believe, and I'm not 100% sure on the terminology inside this, like, civil engineering type question. But grade of road, I believe, is as you are traveling down the road, are you going up or you're going down? And pitch of the road would be like the angle that you are on the road. Does that kind of make sense? So like if so in a racetrack, especially when the cars are going like at Formula One speeds, NASCAR speeds, those are like close to 200 miles per hour. And they're taking these corners. Okay, if these corners are flat, okay, then when that car turns, because of the centripetal force, that car is going to get pulled away from the track. Does that make sense? Okay, if you anybody ever travel down, do you guys have your driver's licenses yet? Okay, so somebody go down like Slabtown out by State Road, and it's got that S curve. If you take that S curve real fast, because there's no angle to the road, there's no pitch to the road, you might go off into the cornfield. Okay. So what happens in like racing was that they will angle, and they do this also on like traditional roads, is that there will be a pitch to the road. Okay. So this road is, if you're sitting in that car, you're kind of at an angle. Does that kind of make sense? If you're stopped, does that make sense to everybody? And this angle right here would be, I think, referred to as the pitch. Okay. I could be wrong with that, but that's what that was talking about. When it talks about the grade of the road is if you are traveling down the road and you start going up the overpass, that increase of going up the overpass is referred to as the grade of the road. Is that okay with everybody? Okay. So, no, the grade of the road, what would be another mathematical word for grade of the road? Let's go from like a side view of an overpass. So let's say we've got our overpass right there. Okay, so you're driving here, and you start, awesome car. You start going up, right? Okay, so this angle right here is referred to as the grade of the road. Does that make sense? Can you view that as maybe the slope of the road? Does that make sense? Okay. You guys, anybody ever travel through the mountains? You ever come across a sign that looks like this? All right. So that's the grade of the road, 7%. Okay. Which means, and because it's provided as a percentage, instead of saying over the next 100 feet, you are going to decrease in height or altitude 7 feet, they provide it as a percentage. Does that make sense? So 7% decrease or 7% increase, how you want to view it, would mean that in a 100-foot stretch of horizontal distance, you are going to fall 7 vertical feet. Does that make sense? Okay. If you've ever run on a treadmill, treadmills have, like, some of them have that incline option on the belt, right? Okay, or the platform. And then it will calculate, as you're running at certain inclines, it will calculate, what was the amount of feet that you elevated in your entire workout. Well, in mathematics, what's happening in that computer is exactly what we're talking about here that we're seeing with the grade of a road. Okay, so on your treadmill, when you change the incline, I think it goes like, mine goes like 1 to 12 or something like that. So I could have a 1% incline, a 2% incline, all the way up to 12% incline. But it means for every 100 feet that I would normally be running horizontally, I'm increasing 1 foot, 2 feet, 12 feet, whatever that percent is. Does that make sense, everybody? So when they say a 7% grade, what they mean is if I was traveling just horizontally for 100 feet, okay, a 0% grade would mean that that road is completely flat and I do not increase at all in the up or down directions. Does that make sense? A 7%, 12%, 15%, whatever, would mean that over 100 feet, I'm going up 7 feet. Does that make sense? Okay. Now, that means that, obviously, this doesn't mean that we're only going to have 7% decrease in the next 100 feet, and after 100 feet, we're back to flat. Okay. This could be over, 100 miles. If I'm going over 100 miles, then that means I would gain a height of 7 miles. Does that make sense? Now, we're not going to, obviously, that would be an issue. But this doesn't have to be 100, and this doesn't have to be 7, but their quotient has to be 7%. Does that make sense? And the easiest way for us to do this, then, is to pick 107. Okay? But if you wanted to go 10 and 0.7, okay, so 10 feet and 0.7 feet, their quotient is still 7%. Okay? What they're asking then, well, what if that's the case, then the road would be the hypotenuse. Is that okay with everybody? So when they say the grade of the road is 7%, what is the angle that the road makes with the horizontal? This would be the horizontal right here. Okay? So the angle they want is that angle right there. So if I call that x, what side would 7 be to x? Opposite. What side would 10 be? Adjacent. So now I would say I would use what trig ratio? Tangent. I say tangent of x is equal to 7 over 10, right? Now what are you going to do to solve for x? Take the inverse. Tangent inverse of the left-hand side, tangent inverse of the right-hand side, and when we calculate that, we go arc tan of 7/10. Make sure I'm in degrees. It's a 35-degree angle that the road makes with the horizontal. Does that kind of make sense? When we talk about the horizontal is so obviously when they're constructing roads, if they can, because it's cheaper this way, to follow the terrain, the natural terrain of the environment, right? Okay. But some roads, especially if you're going through the mountains, they cut out, right? Because the natural terrain might be like straight up, it might be very steep. If they were to cut out to where the road was 100% level, okay, and flat, that is considered the horizontal. Okay. Does that make sense to everybody? What we mean by that? Why I talk about questions like that is, one, they might pop up in your homework, but another thing, my fear I have is that when we take the end of course exam, from time to time, depending on who writes it, they take some liberties in regards to what common knowledge is. Okay. In the past, they've used terminology like this, and a lot of people miss it because they just don't have that common knowledge of what the grade of a road is. Okay. Yes. Did I use 10? I'm sorry. So that should change things. So it's going to move the decimal place. Actually, it does more than that. So 7 over 100. Actually, 4 degrees. So sorry. So I used 10. Apologize for that. Should be 100. Good catch. There's a 4-degree angle. Thank you. Is it okay with everybody? All right, so this next one says a road climbs at an 8-degree angle with the horizontal. So when it climbs within 8 degree with the horizontal, so here's the horizontal, so if my road was carved through the mountainside or the hillside or whatever, okay, but it's not, we're going to follow the natural terrain, so that would be the natural terrain right there, and we're saying that is 8 degrees, okay, not percent, 8 degrees, okay. So what is the grade of the road? Okay, so the grade of the road we just said was the percent of this side divided by that side, right? Well, we don't have either of those sides, do we? It kind of stinks. But when we talk about a grade, we like it to be a percentage, correct? What is the best value to use or to divide by when we're talking about a percentage? We like it to be 100. Okay, so let's just say, and we can make this distance anything we want to. Okay, but what I'm going to do is I'm going to say, okay, if that's 100, if I travel horizontally 100 feet or whatever units, and I know that's 8 degrees, can I find this distance right now of y? Can I say the tangent of 8 degrees is equal to y over 100? Okay, so then y would be, kind of zoomed in on that a little bit too much. Y would be 100 tangent of 8 degrees okay, which gives me that distance. Is that okay with everybody? So if I have an 8 degree grade and I travel 100 feet horizontally, that means I would have traveled 14 feet vertically. Is that okay with everybody? Now remember what it wants as the answer. It wants what is the grade of the road? What is that percentage? Well, the percentage essentially is rise over run. Our rise was 14. Our run was 100, right? That's why I like to use 100. We don't have to. But if I take this number here, let that be my rise. Oh, can't use R here. Let that be that, and then B be 100. Okay. If I take A divided by B, it gives me 14.05%. That's the grade of that road. Does that make sense? Now let's do this. Somebody give me a different number off the top of your head. I'm going to use 6. 10 would be, because 10 is a multiple, or 100 is a multiple of 10, so just want something a little bit different. So let's say if that's 6. Can I still find y if that distance was 6? I can say tangent of 8, okay, is y over 6. So I get 6 tangent of 8. 6 tangent of 8 gives me that number right there, correct? Okay. Now that would be the vertical distance that is traveled when I traveled 6 feet. That make sense? Or maybe it's the vertical distance traveled if I in whatever unit if I traveled 6 whatever units. Does that make sense to everybody? The units just have to be the same. So the vertical distance, which I'm just going to call that distance, call it C right now. If I take C divided by 6, does it still give me the same 0.1405 that gave me? Yeah. Okay. So it does not, in this question, it does not matter what I allow that horizontal distance to be. Okay. In addition to this, I could actually do this problem with finding that and establishing the vertical distance. Let's say I want the vertical distance to be 15. Then I can find what the horizontal distance is that goes with that 15 and 8 degrees, and I can divide them, and it will still give me 14. Does that make sense? Okay, so you got a lot of options there with that particular question. Draw this picture on number 27. So the rectangular box has length 4, width 3, and height 2. Find BD. Find angle GBD to the nearest degree. Take a little bit of time with the people around you. See what you guys can come up with on that one. All right, so this is the situation that we're talking about, right? Okay, now I understand that looking at the printout, it's kind of hard to visualize this, but what they want to know is what is the angle of GBD. So GBD would be this red angle on this interior triangle, correct? Okay. So when they tell us that A to B, okay, that distance there is 4. Okay. So A to B is 4. Let's see if I can put that in here. Okay. They tell us that this distance here is 2. And I believe, do they tell you the width is 3? So they tell you that distance right there. Okay. Now, do I know directly from that information any measurement of that red triangle? Okay, somebody said GD. What do I know GD is? GD is 2, because this side right here, EA, is the same as that one there, right? Okay, so that is 2. Do I know anything else? I can solve for this blue dotted line, right? How can I solve for that blue dotted line? Right. Okay. So if I look at it from the top view, that blue dotted line that is part of that, is the base of that red triangle, is the diagonal of this rectangle, right? And you're saying that if one side is 3 and one side is 4, we should be able to use the Pythagorean theorem to find that dotted line. Okay. Well, if I have a 3 and a 4 as the sides of a right triangle, what is the hypotenuse going to be? 5. Okay. So now if I look at this red triangle, now I know this distance right here. So I'm just going to draw my triangle real quick for us. I know G to D is now 2. The dotted line right here, which I'm going to draw that way, we now know that to be 5, right? And the angle that we're interested in, this angle right there, would be that angle there, correct? Which trig ratio can I use to find that angle? So this is the opposite, and that's the adjacent. Tangent, so say tangent of B is equal to 2/5. So then B will end up being the tangent inverse of 2/5. Everybody agree with that? Okay. So I'm going to type that in real quick. See what Desmos gives us. Tangent inverse of 2/5, 21.8 degrees. Okay. Let's go and actually ask. So what is happening here, and this is the reason I like GeoGebra, is that I've set this thing up to have those conditions that were provided in the problem, right? Okay, this shape is a prism. We're looking at that triangle. I can actually ask this to calculate using essentially a protractor to find out what that angle is. We used geometry and trigonometry, right? If I click on G, B, and then D, gives this green angle right here. So it's 21.8, and we go out rounding like Desmos does, 10 decimal places, 21.8014, 21.8014. Does that kind of make sense? Okay, so the kind of the physics of the image here validates the mathematical calculations that we did. Okay. So something do we understand this? Using that logic, maybe you coupled with some things that we talked about in question 20, because 20 didn't give me any numbers other than the 8 degrees. So using an image or information from 20 and information from 27, see what you can come up with for 28. And there's absolutely no numbers given to you, right? Okay. But there are some relationships there that might exist that we can do this without any numbers. See what you come up with there. What are we going to do to get the kind of the ball rolling with this question? Since there's no numbers. There's no numbers, but what do they tell me the shape is? It's a cube. So what is it? What is a cube? Okay, so it is a six-sided, three-dimensional, call them polyhedrons, but essentially every edge is the same length, right? Okay. So as long as we make that condition true, we should be okay. So if I make them all 1, make them all 3, make them all 7, it shouldn't really matter. Okay. Again, we're trying to find the angle TQS, which is the same as kind of angle GBD was up in 27. When we look at the GeoGebra, it's a little bit easier to see. Okay. So in this case, what I've done is I've allowed each side to be 2. Okay. If you want to make each side 3, that's fine. Okay. It doesn't really matter. Okay. And here's the reason. In order to find this angle, I need to know, obviously, this distance here. What is this distance right there going to be? 3. Okay. Now, I also need this dotted distance along the diagonal of the base. Okay. So if I look at that from a bird's eye view, like this, okay, what kind of triangles are these gray triangles right now? They are the same. They're congruent triangles. But isn't this 3 and isn't that 3? Isn't this a right angle? So it's a right triangle. It's also isosceles, right? What was another way of identifying a right isosceles triangle? It's a 45, 45, 90. So does that tell me if this is 3 and that's 3, the dotted line is 3 radical 2? Does that make sense to everybody? Okay. So keeping that in mind, I'm going to rotate this again. Okay. So the dotted line along the bottom is 3 radical 2. The dotted line right here is 3. So when I draw my triangle, okay, so this dotted line right here is that 3. This dotted line right here is 3 radical 2. Okay. And that is the angle that I'm interested in. So I'm going to use tangent again of angle B is equal to opposite over adjacent. Okay. Now, here's where it doesn't matter. What's going to happen with those 3's? Cancel out. So what if I said this side was 13 and this side was 13? That would have been 13 and that would have been 13, and over here it would have been 13 over 13, and they're going to do what? Cancel out. If it was 131 and 131 radical 2, what's going to happen with the 131s? Cancel out. So as I change these distances, I keep them all the same. Pay attention to this angle down here. If I go make them all 4, does that angle change? No. Make them all 5. Does that angle change? No. Okay. And it's all based on similarity. So the size of the prism doesn't matter to us, or the cube doesn't matter to us. When we take the tangent inverse, it's going to be the tangent inverse of ultimately, after reducing, 1 divided by the square root of 2, and it's going to give me that angle of 35 point, in this case, 26 degrees. Questions on this so far? All right, I've mentioned the word radians, correct? Okay, but we have not talked about what a radian is yet. So let me introduce something for you real quick. We'll do it's off of Twitter actually, but it's an interactive that shows us what a radian is. Find it. All right. What unit are you guys most comfortable with in regards to distance? Would you rather go inches or centimeters? Why? It's what you use all the time, right? It's what you've always used. Okay. Now, centimeters is actually mathematically more intuitive and more beneficial. Okay. So if I had something like 12 inches, okay, does anybody know how I take 12 inches and convert it over into centimeters? I'm going to multiply. So what I'm going to try to do is multiply by something, and on the bottom is going to have a unit of inches. And on the top, it's going to have centimeters, right? Okay. So, and I'm not going to get into the detail of this right now, but like our meter, and this is kind of crazy. Every unit, no matter what system that we're in, is based off of a meter, okay? And a meter's length, okay? This is, I think I got a meter sticker over here. This is not an exact meter, okay? You guys talk about precision in chemistry, correct? This is not an exact meter. And not a single meter ever constructed by man is an actual meter. Does that make sense? Okay, because there's going to be slight variations. Let me see. I should have it somewhere. All right. So, a long time ago, our units were based off of a physical object. Okay. And meter, like if this was a meter, then every meter that I make and disperse would be off of this object, off of this prototype. Does that kind of make sense? And then each one of those would be a little bit different. Okay. And over time, what happens is that the material that this was made out of starts to go through changes. Okay. If we talk about the kilogram, we call it a standard. Its standard was I forget, it was like I think the 1800s or something like that. Was cast in France, and basically 6 replicas of that kilogram were made at that time, and they were dispersed across the world because of trading. Okay, if I am a person that is trading, let's say, coffee beans, and when I think about a kilogram, and let's say that I say a kilogram weighs 2.25 pounds, okay, but where you live, you think a kilogram is 2.3 pounds, there's a difference there that's going to create a monetary difference for me, right? Does that make sense? So we all have to have the same thing to compare what 1 kilogram is to. Well, they did that, and they found out over hundreds of years that those standards started to go through they were made out of metal. I think they were made out of iron. They went through some change. And when they brought all these kilograms back and compared them one another, they were all different. Well, if we're using those as standards, but now somebody in the United States has a different standard or different comparison to somebody in France, there's issue with that. Okay, distances are the same way. Okay, we talk about 12 inches as being a foot, right? So a foot, why is it called a foot? Well, back when we started dealing with distances and needing a need to measure them, they were going off, I think, the average male size of a foot in Europe. Okay. Well, if I'm going off of that being a foot, then when I get to maybe Asia, okay, maybe let's say like China or something like that, a foot is maybe drastically different. Does that make sense? So we need a standard. We need a base, something to base everything else off of. So we were using physical objects. Recently, okay, we are trying to do our best to move away from those, okay, because they change. So in 1983, we redefined the meter, okay, as the length of the path traveled by light, okay. So we're talking about a photon, okay, traveling through a vacuum. So you guys know what a vacuum is? Like a Dyson? Right, we remove all atmosphere from it. Okay, so it's a bubble with no air in it, essentially. Okay, usually made out of glass. Okay, but we suck all the atmosphere out of that. Okay, so we create a vacuum. The distance that the light particle travels, okay, in this fraction of a second, okay, 299,792,458 of a second, that distance, okay, traveled by that photon in that time length is a meter. Does that make sense? And the reason we define it that way, it's approximately this long, okay, like the meter that we're used to, okay, but the reason we do this is because it's in a vacuum and light travels at a constant rate, so this will never deteriorate. This will never change. For the eternity of man, defining a meter in 1983 this way now allows a meter today and a meter in 30,000 years to be the exact same thing. Does that make sense? Okay. That's not always been the case. And kind of getting into that topic that's called unit analysis, because we know that distance of a meter, and we know there is 100 centimeters in a meter, we can basically lay down a centimeter next to an inch, and we find out that there's a conversion that it's 2.54 centimeters to every 1 inch. And if I multiply those together, okay, there's 30.48 centimeters in a foot. Does that make sense? Okay, and that's some conversions that you guys have done. So that allows you to work with something that you're not comfortable with. If we're not comfortable with centimeters, we could change it to feet or inches, and then the feet and whatever we might need. Or if we're not comfortable with feet and inches and miles, we could convert it to centimeters, meters, kilometers, however we might see fit. So we have conversions that allow us to do something like that. Now, same thing happens when we talk about angle measurements. Angle measurements, the unit that you are most comfortable with is degrees, right? Okay. I'm going to show you the better unit to identify angles with. Okay. We said that the better unit to talk about in regards to distances is using the metric system, using centimeters, meters, and the like. Okay. This is going to demonstrate what a radian is. Okay, so I'm going to start this over real quick. There used to be like a pause button on here I could use, but so what they're going to do is they're going to draw out a circle. That red distance is called the what for the circle? Radius. Okay? We're going to take that radius. That distance right there was the same length as the radius. Okay, let me see. No, I don't want to do that. I just want to pause it. There we go. All right. I apologize for... All right. So there's my radius of my circle, correct? Okay. It's going to travel out and rotate it. It's going to create that circle. Okay. Now, it doesn't matter how big the radius is. Doesn't matter. It could be 2 inches. Could be 2 miles. Does not matter. We're going to take that radius, and we're going to take it out. And right there, if it started off as 2 inches, it's still that distance is still 2 inches. That makes sense? Or if it was 2 miles, that distance is still 2 miles. I'm going to curve that distance. And I'm going to put it right there. That is still 2 inches or 2 miles, whatever unit we chose. Does that make sense? Okay. When I look at that angle that is made right there, that angle in regards to degrees, it's about 60 degrees. But that is 1 radian right there. Is that okay with everybody? Now, the reason that it becomes very convenient for us is that we can take that 1 radian, cut and paste it. Now we got 2 radians, right? Cut and paste it again. We've got 3 radians. Okay? Now, I want to get to the x-axis here. And this little sliver right here is 0.14159 radians. Which when I add 3 radians to that, it gives me pi radians. How many degrees would this be? 180 degrees is equivalent to pi radians. That's our conversion factor. That's the same as saying 1 inch is 2.54 centimeters in distance. 180 degrees now is the same thing as pi radians. Now, the reason this is nice is because when I go all the way around, we get 2 pi radians. Okay? And something that we talk about in a trig class eventually is if that's 2 pi radians, and I like multiplying and dividing by 1, okay, because that's a really nice thing to multiply and divide by because it doesn't change anything, right? So what we end up doing is saying, okay, that circle had a radius of, instead of 2 or 5 or 12, let's make that circle have a radius of 1. Okay? So what is the formula for circumference of a circle? It's 2 pi r, right? Okay? The 2 pi comes from this relationship right here. Okay? If r was 1, 2 pi r, this circumference right now is 2 pi, 6.28 units. Okay? So we have a conversion that, so when we say 2 pi radians, that's equivalent to 360 degrees. All right? Something we work on in a trig class, if I want, so if I take 180 divided by pi, that right there tells me that 1 radian is about 57.3 degrees. Okay? And that's the conversion factor. We go to back and forth between radians, okay, and degrees. Now, that's the reason why on our calculator we need to make sure we're in the right mode. Because if we're not in the right mode, so if I put like, let's say my calculator is in radians, but I want it to be in degrees, and I type 57 in as a degree, it's actually saying 57 radians, which would mean that I have 57 of these highlighted numbers. 57 times 57 essentially would be what I'm putting in as my angle measurement. Does that make sense? So the calculator is doing that conversion factor, and that's why we need to make sure that we know what mode we're in. Okay? We'll stop there talking about radians. Maybe talk about it a little bit more tomorrow. My goal by the end of the week, guys, is to get through 8.4. Should not take us long. I think talking about these types of problems is a benefit to getting through 8.4 a little bit more efficiently than what we have in the past. Next week we'll talk about laws of sines and laws of cosines, and we'll have a test next Thursday. I'm also going to Friday. You're because it's an e-learning day on Friday, correct? Okay. So I'm going to have an assignment. I'm going to grade it like a test or a quiz, but I'm going to set it up like a homework. Okay. So you'll have multiple chances on it, that kind of thing. But I want to gain you some points. So it's going to be more than the 5 or 10 points that homework generally is. And we'll talk more about that tomorrow.